Acids and bases. There are several definitions of acids and bases. The one I'm going to give you is called the Bronsted-Lowry definition. This is the most common definition. Acids are proton donors, and bases are proton acceptors. By proton, they mean H+, because if you think about a hydrogen atom has only one proton and one electron. If it becomes a hydrogen ion, that's all it is a proton. So by a proton donor, they mean something that gives up H+ ions in solution. By a base, they mean something that accepts that H+ ion. Now, it makes a difference if something is classified as a strong acid or a weak acid, a strong base or a weak base. Here are the strong acids. There are 7 of them. Memorize them. HCl, HBr, HI, HNO3, H2SO4, HClO4, HClO3. You'll notice HF is not on this list. HF is a weak acid. These are the only strong acids. Now, a strong base is a group 1 or group 2 metal or group 2 ion bonded to OH minus. Those are the strong bases. Sodium hydroxide, potassium hydroxide, strontium hydroxide. Strong bases. Any other kind of base is a weak base. Now, what does it mean to be strong or weak? Strong means complete dissociation in water. So, in water, HCl is not HCl. It's really H+ plus Cl minus. In water, NaOH isn't NaOH. It's really Na plus and OH minus. Again, think about like a net ionic equation. When you're writing a strong acid or a strong base in the net ionic equation, you completely dissociate it just like you would an ionic salt. Weak acids and bases do not completely dissociate in water. In fact, they dissociate very little in water. Later, we're going to get to why and how much. But for right now, just know weak things don't dissociate very much in water. Let me give you an example. HCl plus NaOH, that's a strong acid plus a strong base. Remember that strong things completely dissociate. The product of this reaction is going to be, this is your regular, ordinary, everyday double replacement reaction. The H is going with the OH, the Na with the Cl. So I've got aqueous acid and aqueous base going to liquid water plus this aqueous compound, NaCl, which is called a salt. I know it's also table salt, but an ionic compound is called a salt. Salt is a class of compounds. When an acid reacts with a base, you get water and a salt. Now, that's the regular equation. I want the net ionic equation. Remember that this guy completely dissociates, H plus Cl minus. And this guy completely dissociates, Na plus OH minus. And this ionic compound completely dissociates, Na plus Cl minus. So the Cl minuses are going to cancel. The Na pluses are going to cancel. The net ionic equation is going to be H plus OH minus yields liquid water. That is always the net ionic equation for a strong acid plus a strong base. It doesn't matter which strong acid or which strong base, that's the net ionic equation. If I have a strong acid plus a weak base, HCl plus ammonia. Okay, again, HCl doesn't get written as HCl. It's going to be written as H plus because the Cl minus is going to be a spectator ion. The anion of the strong acid is always a spectator ion. It always goes away. So H plus, weak bases, not dissociating. So I'm just going to write that. So H plus NH3. Now what's a base? By definition, it's a proton acceptor. So it's going to accept the H plus and become NH4 plus. That's the pattern for the strong acid weak base equation. The strong acid is always going to be written as H plus. I write the weak base, and then whatever that weak base is, I'm going to add an H and give it a plus charge. Notice the charges are balanced in my net ionic equation. The other possibility is the strong base plus the weak acid. So I'm going to write acetic acid plus OH minus. There's the strong base. It doesn't matter whether I'm talking about sodium hydroxide or potassium hydroxide or lithium hydroxide. Doesn't matter. Weak acid, strong base. Again, base, proton acceptor. So that's what it's going to do. Remember, the weak acid does not get dissociated in the net ionic. But the two ions here are H plus and the acetate ion. So the H plus is going to react with the OH minus and give me water. And I just have the anion. Notice again, this is balanced. Even the charges are balanced. There's my acetic acid plus OH minus goes to water plus the acetate ion. This is the pattern for weak acid plus strong base. The weak acid, not dissociated, plus the OH minus of the strong base goes to water plus whatever the anion of the weak acid was. So it's all about recognizing the pattern and following the pattern.